What are network topologies? A topology is the layout of how a network communicates with different devices. There are a couple of different network topologies. They can be wired and wireless. The most common topology is star topology, where each and every device is connected to the central device, mostly hub or a switch. The data is transferred to each and every node in the network through this device. If there is a wire breakage in any of the node or the node itself not functioning properly, then there will be no effect on the entire network. It works smoothly without any data delay. When the centralized device, hub or switch stops working, it causes the failure of the entire network. The next topology is ring, where each node is connected to each other in the form of a ring or a loop. These are connected in a fashion where each node has exactly two neighbors. Any breakage in the ring will cause the whole network failure. The next topology is bus, which is rarely used today. In this topology, every node is connected to the centralized cable, which is normally a coaxial cable, also known as backbone of the network. The backbone or centralized cable must be terminated at the ends. The most commonly used and reliable topology is known as mesh, where each and every node or device in the network is connected with the other one. Here you can see there are four devices connected to each other, and there are three paths from each computer or node towards the other one. The failure of a single route or cable doesn't affect the data transmission. This is known as data redundancy or transmission redundancy, where the other routes can be adopted. The best example of mesh topology is Internet, which connects millions and billions of nodes or devices globally. The OSI model was introduced by ISO in 1983, which makes sure that each and every kind of device can be connected to the network. The seven layers of OSI, physical, data link, network, transport, session, presentation, and application, make sure the safe data delivery from source to destination. There is a key sentence to remember all these names. From top to bottom, all people seem to need data processing. Each layer provides services to the next layer in order to make sure the safe data delivery. Physical layer deals with the physical devices in order to make sure the data delivery. If there is a wire, then data will be transferred through electric signals and the Wi-Fi through radio waves. And if there is fiber optic, then the data will be transferred through light signals. The data link layer establishes a link between source to destination for the accurate delivery of data packets. Here MAC address is required, the media access control, which makes sure the data delivery to the exact node. The IP addresses are assigned to each node in the network layer, and the router makes sure that data should be reached to the destination precisely and accurately within the network. Next is the transport layer, which manages the speed between different systems in the network and also controls the errors in the data flow or data segments within the network. The session layer creates and manages the session between source to destination until and unless each packet or segment of the data is accurately transferred from source to destination. The presentation layer encrypts the data, means that it converts the data into the form that is not readable even by the hacker if it hacks the data between the source and the destination. The correct data display in the relevant application is the responsibility of application layer. Here the protocols FTP, SMTP and HTTP are used.